All right, we are almost done learning the new stuff, and then we can start reviewing for the AP exam. We still have some more integration techniques we need to learn. So far, we've done regular integration with indefinite integrals and definite integrals, and we've done U substitution, and we've done integrals that end up as inverse trig functions. I have 3 warm-up problems here that I want you guys to take a look at. Today's lesson is going to focus on rational functions when you're integrating rational functions. And if you remember, a rational function has a numerator and a denominator. So if you look at our 3 warm-up problems, we have a numerator and a denominator, a numerator and a denominator, a numerator and a denominator. And I have a hint for you right here for number 3. I will give you a hint for this first one. Since we have a denominator that is a single term, you can split that numerator up and divide them each by x cubed and then integrate the individual pieces. This one's going to require a U substitution, and this will also require a U substitution. So I would like you to pause the video and try those 3 warm-ups, and then when you come back, when you unpause, they will be done. We'll check your answers. Okay, so I'm back. For number 1, I ended up integrating 1 minus 4x to the negative 1, right, because 2 minus 3 is negative 1. The integral of 1 is x. Pulled the 4 out. The integral of x to the negative 1 is the natural log of x, of the absolute value of x. Don't forget your plus c because it's an indefinite integral. Guarantee you're going to have something with a plus c on one of these free response questions. Okay, so hopefully that's what you got for that problem. You do not have to do this step. You can go right from here to here, and that will be perfectly acceptable. For number 2, I let u equal 7 minus 2x. Du is negative 2 dx. Negative 1/2 du is equal to dx. Hopefully you're starting to recognize some patterns here after doing these. You can almost kind of start to do these in your head. I pulled the 3 out from the top so that it's 1 over u times negative 1/2 du, right? Dx got replaced with negative 1/2 du. I pulled the negative 1/2 out. 3 times negative 1/2 is negative 3/2. The integral of 1 over u is the natural log of u. And since it's an indefinite integral, I have to replace that u with 7 minus 2x. Don't forget the plus c. And for the third problem, here the third warm-up, I noticed that this fit nicely into this formula. A squared was equal to 9, so that means that a is 3. U squared was equal to 16x squared, which means that u is equal to 4x, which means du is 4 dx, which means that 1/4 du is equal to dx. So I rewrote it. I have hiccups, excuse me. I have my general formula here. I just moved the du to the end. I'm not a fan of du in the top. I like to have it at the end. But I do know that the dx got replaced with 1/4. So I have 1/4 du here. I pulled the 1/4 out. I applied the formula 1 over a, and remember my a is 3, so 1 over 3 times the inverse tangent of u over a plus c, and then all I did was simplify the 1/4 and the 1/3 to get 1/12. Okay? Unfortunately, these 3 strategies are not the only strategies for integrating rational functions. Okay, so anytime you see these problems, when you have a numerator and a denominator, that's a rational function, and we have multiple strategies. We can do the division, split it up, and integrate each part. We can do a U substitution, or it may end up being either an inverse sine or an inverse or an inverse tangent. But sometimes they don't work with certain rational functions, so we need other strategies. Dum dum dum. I'm not sure how you spell that. I actually spent like 5 minutes trying to figure out how to spell that. Okay, so in this video, I'm going to introduce 3 more strategies, and that's it. I promise you there's no more. And in this video, we're only going to talk about the first bullet here. So rational integrals. If the strategies used in the warm-up don't work, we may have to try 2 different strategies. Actually, it should be 3. Long division, which is the first bullet. Completing the square, which is this bullet, which will be the 3rd video. And we kind of have already done what's in the 2nd bullet, but we'll do a little review just to make sure that you remember how to do it. Okay, so we use long division if the degree of the numerator is greater than or equal to the degree of the denominator. So if it's top heavy, if you remember that phrase from pre-calc last year, if the degree up top is more than the degree on the bottom, so like this is an example. The degree up here is 2 and the degree down here is 1. Okay, if it's greater than or equal to, and the denominator is not a single term. So let's think about this. Let's go back and look at our first warm-up. The degree of the top and the degree of the bottom were equal, but I didn't have to use long division because this was a single term. If you look at this example over here, the denominator is not a single term. That's my clue that I'm going to have to use long division. And we did this in pre-calc last year. I don't know if you remember how to do long division, but I'm going to do 1, 3, and 5 with you. Maybe 7, we'll see. I may leave that for you guys to try it on your own. But let's do long division here. I'm going to switch colors. So we're going to divide the top by the bottom. So x plus 2 is going to divide into x squared minus x minus 5. Okay? So what we want to do is we want to figure out, we look at our first term. What can I multiply x by to get x squared? Well, hopefully you said x, and we're going to line things up. Right? This has a degree 1, so I'm going to line it up over degree 1. I'm not going to put it over here. I'm not going to put it over here. And then I'm going to multiply. X times x is x squared. X times positive 2 is positive 2x. And then I'm going to subtract. X squared minus x squared cancels. We want that first term to cancel, so if it doesn't cancel, you did something wrong. Negative 1 minus 2 is negative 3x. And I can pull down that negative 5. And now I repeat the process. So x times what gives me negative 3x? Hopefully you said negative 3. That's a constant, so it's going to line up over the constant. And I'm going to multiply. Okay. Negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And I subtract. Negative 3x minus negative 3x, minus a negative is a positive, so that cancels. Negative 5 minus a negative 6 is positive 1. So that means that this problem can be written as x minus 3 plus a remainder divided by our divisor. Right? So that means that this integral can be rewritten as x minus 3 plus 1 over x plus 2 dx. Okay? Just think about this. If I give you 4 into 26, we know that 4 goes into 26 6 times with a remainder 2. So that means that it's 6 plus 2 divided by 4. It's 6 plus 1/2. It's our answer from the top plus our remainder divided by our divisor. That's all I did here. Our answer from the top, which is right here, plus the remainder divided by our divisor, 1 over x plus 2. That's where that came from. And now, since we have these separated with plus signs and minus signs, I can integrate. So I'm actually going to split this up. I'm going to do the integral of x minus 3 dx plus the integral of 1 over x plus 2 dx. Okay. So the integral of x is 1/2 x squared. The integral of negative 3 is negative 3x. Hopefully, by now you have recognized that this is a u substitution. U is equal to x plus 2. Du is equal to dx. So that just becomes the integral of 1 over u du. And you can actually, if you start to recognize this pattern, you don't even have to write that stuff out. So I get 1/2 x squared minus 3x plus the natural log of u, which is x plus 2, throw it in absolute value signs, plus c. These are not the prettiest answers in the world, but that's how you do them. Okay, let's take a look at number 3. Ooh, I'm actually going to pause this and make another video. I'm going to stop it and make another video because this one's almost 10 minutes.